Objects. Introduction to objects. It's time to learn more about the basic structure that permeates nearly every aspect of JavaScript programming. Objects. You're probably already more comfortable with objects than you think, because JavaScript loves objects. Many components of the language are actually objects under the hood, and even the parts that aren't, like strings or numbers, can still act like objects in some instances. There are only 7 fundamental data types in JavaScript, and 6 of those are primitive data types: string, number, boolean, null, undefined, and symbol. With the 7th type, objects, we open our code to more complex possibilities. We can use JavaScript objects to model real-world things, like a basketball, or we can use objects to build the data structures that make the web possible. At their core, JavaScript objects are containers storing related data and functionality. But that deceptively simple task is extremely powerful in practice. You've been using the power of objects all along, but now it's time to understand the mechanics of objects and start making your own. Let's go to the next lesson. Creating object literals. Objects can be assigned to variables just like any JavaScript type. We use curly braces to designate an object literal. Let spaceship equal curly braces. Spaceship is an empty object. We fill an object with unordered data. This data is organized into key-value pairs. A key is like a variable name that points to a location in memory that holds the value. A key's value can be any data type in the language, including functions or other objects. We make a key-value pair by writing the key's name or identifier, followed by a colon and then the value. We separate each key-value pair in an object literal with a comma. Keys are strings, but when we have a key that does not have any special characters in it, JavaScript allows us to omit the quotation marks. Let spaceship equal, and then it opens an object and it has fuel type as a string and diesel as a string, and then color as not a string, and silver. So you can do the string name without putting the quotation marks around it. An object literal with 2 key value pairs, let spaceship equal fuel type diesel, color silver. The spaceship object has 2 properties, fuel type and color. Fuel type has quotation marks because it contains a space character. Let's make some objects. Instructions. The spaceship we have so far looks good, but unfortunately is not very fast at hyperspace travel due to having an inferior fuel source. Make a new spaceship object named fastership with the same color as spaceship, but with a fuel type equal to turbo fuel. So it needs to be the same as the one they gave us. So here we are. Now, let's write it out with a let, I guess. And this was faster ship. And that will equal those open curly braces. And we have to do quotes around fuel type, because there is a space between fuel and type. That's what makes that necessary. And it has to have the same color, but needs turbo fuel. Okay, so the fuel type will be turbo fuel. And we comment to the next part, which is color. So that's the next property. And the color will be the same color, which was silver. All right, let's run that. And we did it. We can move on to the next lesson. Accessing properties. There are 2 ways we can access an object's property. Let's explore the first way, dot notation. You've used dot notation to access the properties and methods of built-in objects and data instances. Hello.length returns 5, hello being a string, of course. With property dot notation, we write the object's name followed by the dot operator and then the property name or key. Let spaceship equal an object with home planet Earth and color silver. Spaceship.homeplanet would return Earth. spaceship.color would return silver. If we try to access a property that does not exist on that object, undefined will be returned. Spaceship.favoriteicecream returns undefined. Let's get some more practice using dot notation on an object. Instructions. Let's use the dot operator to access the value of numCrew from the spaceship object in the code editor. Create a variable crew count and assign the spaceship's numCrew property to it. All right, let's create our variable. I'll just call it const crew. It was crew count. There it is. Const crew count was from here. It's the variable we're making. We want to set it equal to the numCrew property of spaceship. Okay, so the numCrew property of spaceship. So you want to say spaceship dot numCrew. And let's try that out. And that worked. Again, using the dot operator, create a variable planet array and assign the spaceship's flight path property to it. Okay, so const planet array will equal spaceship dot flight path. And we'll run that. Great, that's working properly. Let's move on to the next lesson. Bracket notation. The second way to access a key's value is by using bracket notation, and those are square brackets. You've used bracket notation when indexing an array. An array holding strings A, B, C at 0 would return the first value of that array, which was A. To use bracket notation to access an object's properties, we pass in the property name key as a string. Object spaceship, and then the property name in square brackets, fuel type, as a string. We must use bracket notation when accessing keys that have numbers, spaces, or special characters in them. Without bracket notation in these situations, our code would throw an error. They let spaceship and has a fuel type, which is two different words, active duty, two different words, then home planet and crew. And when they say spaceship, they open up their square brackets and put in active duty as a string. It returns true, fuel type returns turbo, numCrew returns 5, and this one, which is just exclamation points, is going to return undefined because spaceship does not have an exclamation points property. With bracket notation, you can also use the variables inside the brackets to select the keys of an object. This can be especially helpful when working with functions. Let return any prop equal, and it takes in object name and prop name, and then we have our fat arrow function. It says object name and prop name is in square brackets, and it returns any prop with spaceship and home planet, and it should return Earth in our case. If we tried to write our return any prop function with dot notation, object name dot prop name, the computer would look for the key of prop name as a string in our object and not the value of the prop name parameter. Let's get some practice using bracket notation to access properties. Instructions. Let's use bracket notation to access the value of active mission from the spaceship object in the code editor. Create a variable isActive and assign the spaceship's active mission property in it. So we want a const isActive, and that's going to equal spaceship and then square brackets, quotes, active mission. Let's try that out. Great. 2. Using bracket notation and the prop name variable provided, console.log the value of the active mission property. Okay, console.log spaceship active mission, and gotta be a space. Let's try that out. I think that's what they're asking. That is it. Great. Let's move on to the next lesson. Property assignment. Once we've defined an object, we're not stuck with all the properties we wrote. Objects are mutable, meaning we can update them after we create them. We can use either dot notation or bracket notation and the assignment operator, the equal sign, to add new key value pairs to an object or change an existing property. The object, spaceship, the property name would be fuel type or color. Then you have the assignment operator, the equal sign, and the value that you're going to assign to it, where they have the fuel type being vegetable oil as a string and the color being gold as a string. One of two things can happen with property assignment. If the property already exists on the object, whatever value it held before will be replaced with the newly assigned value. If there was no property with that name, a new property will be added to the object. It's important to know that although we can't reassign an object declared with const, we can still mutate it, meaning we can add new properties and change the properties that are there. Const spaceship equals an object with a type of shuttle. Spaceship equals type alien. That will give you a type error assignment to a constant variable. Spaceship.type equals alien changes the value of the type property. Spaceship.speed equals Mach 5 creates a new key of speed with a value of Mach 5 as a string. You can delete a property from an object with the delete operator. Const spaceship equals, and then it opens up an object with a fuel type turbo fuel, home planet Earth, mission, explore the universe. Delete spaceship.mission. That removes the mission property. Instructions. Reassign the color property of the spaceship object to have the value of glorious gold. Okay, so we saw how to do that. We have to type in spaceship, and we could either go with the dot operator, and that's what I'm going to use here because we don't need a space like we would right here or right here. So I'm going to use the dot operator to go to color, and then I'm going to assign to spaceship.color glorious gold. And let me run that. That worked. Without changing lines 1 through 6, add a num_engines property with a numeric value between 1 and 10 to the spaceship object. All right, let's do that. We're just going to make a new property here because we don't have a num_engines here. So spaceship.num_engines, that is going to equal 10. I want the maximum amount of engines, and I don't see if they wanted the, oh no, they said numeric value, so we won't do a string, and let's run that. 3. Use the delete operator to remove the secret mission property from the spaceship object. Okay, so that was pretty straightforward. It was delete, and then what you wanted to delete, so spaceship dot mission they wanted, secret mission. Oh, no dots, so we'll have to open up our square brackets because we have a space in secret mission. Secret space mission. That's funny, this is a secret space mission. And we'll run that. Great, we can move on to the next lesson. Methods. When the data stored on an object is a function, we call that a method. A property is what an object has, while a method is what an object does. Do object methods seem familiar? That's because you've been using them all along. For example, console is a global JavaScript object, and .log is a method on that object. Math is also a global JavaScript object, and .floor is a method on it. We can include methods in our object literals by creating ordinary, comma-separated key value pairs. The key serves as our method's name, while the value is an anonymous function expression. Const alien ship equals, and then we have an object open, and we have a property called invade, which is a function, and it console logs, hello, we have come to dominate your planet. Instead of Earth, it shall be called New Exelon. With the new method syntax introduced in ES6, we can omit the colon in the function keyword. Const alien ship. Okay, so just invade, you won't have to have invade colon then function. You can have an invade function just like that. Okay, that is good to know. Object methods are invoked by appending the object's name with the dot operator followed by the method name and the parentheses. So alienship.invade and then invoke that function will print out the console log that was held inside of alienship in the function invade. Instructions. Below the retreat message variable in the code editor, create an alienship object. It should contain a method.retreat, which will console.log the retreat message. Let's create our alien ship. So const alien ship equals, this is going to be an object. That's the curly braces. That's what we want to put in there. And inside of there, we need a dot retreat, which will console log the retreat message. So the way they did it, you could just type in retreat like so, and then do that. Let's make sure we're doing this right. See, we have invade, then we invoke, and then we open our function. And we could do our work inside of here, and it wants us to console.log the retreat message, which is up here. So I think that's what it's asking us to do, and we're going to run it and give it a shot. Yes, that's it. Add another method to your object literal. This method, .takeoff, should console.log the string spim-borp glix blastoff. That's the sounds of the alien ship, I imagine. So let's do takeoff. And that will console.log, and I'm definitely copying and pasting this. All right, let's try that out. Oh, I did something wrong. Oh, I didn't comma between. So that's it, I didn't comma between. That's what was wrong there. So we need to put commas between each piece of this. So if we're kind of seeing what's going on here, we have retreat, that ends, there's a comma. We have takeoff, that ends. There's nothing after it, so we don't need a comma there, but we would comma to the next thing as well. Invoke your two methods, first retreat, and then takeoff. Okay, so we need to invoke them. So we'll just say alien ship dot retreat. And we invoke that, and then alien ship dot takeoff, and we'll invoke that. Let's try that out. Looks great. Let's move on to the next lesson. Nested objects. In application code, objects are often nested. An object might have another object as a property, which in turn could have a property that's an array of even more objects. In the spaceship object, we want a crew object. This will contain all the crew members who do important work on the craft. Each of those crew members are objects themselves. They have properties like name and degree, and they each have unique methods based on their roles. We can also nest other objects in the spaceship, such as a telescope, or nest details about the spaceship's computers inside a parent nanoelectronics object. Const spaceship, and we could see how deep we could go in here. Let's just do one of them where they say crew here. So we have a spaceship, which is an object, and then it can have telescope, which does have an object inside of it. Now we have crew. So we have crew here, so it would be spaceship.crew, and say we want to see the captain.captain, that'd give us this entire object. Then .name would finally give us Sandra. Let's see their explanation. We can chain operators to access nested properties. We'll have to pay attention to which operator makes sense to use in each layer. It can be helpful to pretend you are the computer and evaluate each expression from left to right so that each operation starts to feel a little more manageable. Spaceship.nanoelectronics, square brackets, the string, backup.battery returns lithium. In the preceding code, first, the computer evaluates spaceship.nanoelectronics, which results in an object containing the backup and computer objects. We accessed the backup object by appending backup, and that was in square brackets, and it's a string. The backup object has a battery property accessed with .battery, which returned the value stored there, lithium. Instructions. Create a variable capeFav and assign the captain's favorite food, the element in the 0th index of her favorite foods array, to it. Okay, let's do that first before we keep going here. So we need to get to the captain's favorite food to the first piece of the array. So her favorite food is cookies. So we could keep this in screen here so we could still see it. And after that, we want to have a const capFav. That's going to equal the captain's favorite food. So first we go into spaceship. We're probably going to be able to dot. Let's see. A lot of them are dots. So spaceship.crew.captain. And then we have to go to favorite foods, and that needs to be in square braces because we need to do a string since there's a space. So favorite foods. And then we actually need the first one from the favorite foods. So I'm guessing we're going to put it right here to make this work. So let's run this and see what happens. Nope, that is not working. So the 0th index of the favorite food. Oh, let me get this off the screen, meaning that this needs to be outside. So inside, it doesn't help, but outside of the brackets, we'll get to the 0th element. Let's run that. All right, let's move on to number 2. Right now, the passengers property has a value of null. Instead, assign as its value an array of objects. These objects should represent the spaceship's passengers as individual objects. Make at least one passenger object in the array that has at least one key value pair on it. Okay, so spaceship should have a passengers and it's null. Okay, so we're going to assign something to that. So spaceship.passengers, and then we can start assigning. Spaceship, yep, it's all undercase, dot passengers equals, and we want to assign as its value an array of objects. So here's an array, here's an object, comma, here's another object. And in these objects, they want their passengers, so they want people. So we're just going to go name, Jim, and then name, Jane. And we could keep on making other things, their ages, stuff like that, but we need at least one key value pair, so we're just going to do one each, and we'll run it. Good to go. Number 3, create a variable first passenger and assign the first passenger as its value, the element in the 0th index of the spaceship.passengers array you just made. Make sure to use bracket and dot notation to get the passenger object through nested access. Don't just copy the object into the variable. Let's do what it says with our const first passenger equals spaceship dot, and then it was passengers. And then we want the 0th element, 0. Let's try that out, see if that's what they wanted. That works. Let's move on to the next lesson. Pass by reference. Objects are passed by reference. This means when we pass a variable assigned to an object into a function as an argument, the computer interprets the parameter name as pointing to the space in memory holding that object. As a result, functions which change object properties actually mutate the object permanently, even when the object is assigned to a const variable. Const spaceship equals object with home planet and color. Home planet's Earth, color is silver. Let painted equal, it takes in an object, and it's a fat arrow function. It returns object.color equal to glorious gold. Painted spaceship, spaceship.color should return glorious gold. Our function painted permanently changed the color of our spaceship object. However, reassignment of the spaceship variable wouldn't work in the same way. Let spaceship as an object, home planet Earth, color red. Let try reassignment equal object, fat arrow function, object equals, it opens a new object, identified is false, transport type is flying, console.log, object prints identified false, transport type flying. Try reassignment spaceship. The attempt at reassignment does not work. Spaceship still returns home planet Earth, color red. Spaceship equals identified false, transport type flying. Regular reassignment still works. Let's look at what happened with the code example. We declared this spaceship object with let. This allowed us to reassign it to a new object with identified and transport type properties with no problems. When we tried the same thing using a function designed to reassign the object passed into it, the reassignment didn't stick, even though calling console.log on the object produced the expected result. When we tried the same thing using a function designed to reassign the object passed into it, the reassignment didn't stick, even though calling console.log on the object produced the expected result. When we passed spaceship into that function, object became a reference to the memory location of the spaceship object, but not the spaceship variable. This is because the obj parameter of the try reassignment function is a variable in its own right. The body of try reassignment has no knowledge of the spaceship variable at all. When we did the reassignment in the body of try reassignment, the obj variable came to refer to the memory location of the object, identified false transport type flying, while the spaceship variable was completely unchanged from its earlier value. Write a function green energy that has an object as a parameter and sets the object's fuel type property to avocado oil. Okay, so I'm going to fat arrow function, so const green energy equals the fat arrow taking in an object, we'll say obj, and we need to assign the object, and not dot, but square brackets, fuel type, and that will be equal to avocado oil. And let's run that and see if we did it right. We did. Write a function remotely disable that has an object as a parameter and sets or reassigns the object's disabled property to true. Okay, so const remotely disable fat arrow function, and it should also take in an object again. So we'll take in the object, and we will object, and then the property was disabled, so let's just dot disabled equals true. Let's run that. That looks good. Call your two functions with the spaceship object in the code editor, then console.log the spaceship object to confirm those properties were changed/added. So we need to call these two functions. So we need to say green energy, and then we pass in spaceship. And we also need our remotely disable spaceship. And those are both functions like so. And then they want us to console.log spaceship so we can see what happens. And let's give that a go. We can see that the fuel type was changed to avocado oil, and remotely disabled is now true. Great, let's move on to the next lesson. Looping through objects. Loops are programming tools that repeat a block of code until a condition is met. We learned how to iterate through arrays using their numerical indexing, but the key value pairs in an object aren't ordered. JavaScript has given us alternative solution for iterating through objects with the for in syntax. For in will execute a given block of code for each property in an object. Let spaceship and then the entire spaceship value, and we see there's a lot in here, and we want to focus on the for in part of it. So for let crew member in spaceship.crew. The console.log, they are string interpolating crew member, and then string interpolating spaceship.crew, crew member in square brackets .name. So they're going to console.log all of their names. Our for in will iterate through each element of the spaceship.crew object. In each iteration, the variable crew member is set to one of spaceship.crew's keys, enabling us to log a list of crew members' roles and name. Instructions. Using for in, iterate through the spaceship.crew object in the code editor and console.log a list of crew roles and names in the following format: crew member's role, crew member's name. Example, Chief Officer Dan. Okay, so we have spaceship.crew, and then the crew is labeled with their roles. So captain, medic, translator, and they each have names in the object, which they hold their name, degree, and some other stuff, this announce function here. So let's get started. For, let's let role in spaceship.crew and console.log what we need to do here. So what we'll want to do first is our backticks. So we could do string interpolation, and the first string we want to do string interpolation on is role, because that'll be medic, translator, captain, that'll be the role. And we need our colon, and we need our next piece, which is going to be more than just pulling off of role. We're going to have to go to spaceship.crew. And then we have to pass in role and .name. So spaceship.crew, and then we'd get medic.name should bring up that. Let's see if we're right. That works, great. Captain Lily, Chief Officer Dan, medic Clementine, and translator Shauna. Using for in, iterate through the spaceship.crew object in the code editor and console.log a list of the crew's names and degrees in the following format: crew member name, crew member's degree, i.e. Lily, computer engineering. Okay, we could do that as well. We saw how we get to the name, and we want to do the entire crew. So we have to do it the same way. So we're going to do spaceship.crew again. For let role in spaceship.crew and console.log and get our backticks up. And we need the crew member's name. We know how to do that. That's this entire thing here. So just put your $, get that in there. That gets to the crew member's name. What do they want after it? They want a colon, a space, and then we could start crew member's degree. So it's going to be the same type of thing, spaceship dot crew, then the role, then dot degree. Take a look, make sure I did these the same. Yeah, that's looking pretty good. Let's give it a run. Let's go to the next lesson. Review. Way to go. You're well on your way to understanding the mechanics of objects in JavaScript. By building your own objects, you will have a better understanding of how JavaScript's built-in objects work as well. You can also start imagining organizing your code into objects and modeling real-world things in code. Let's review what we learned in this lesson. Objects store collections of key-value pairs. Each key-value pair is a property. When a property is a function, it is known as a method. An object literal is composed of comma-separated key-value pairs surrounded by curly braces. You can access, add, or edit a property within an object by using dot notation or bracket notation. We can add methods to our object literals using key-value syntax with anonymous function expressions as values or by using the new ES6 method syntax. We can navigate complex nested objects by chaining operators. Objects are mutable. We can change their properties even when they're declared with const. Objects are passed by reference. When we make changes to an object passed into a function, those changes are permanent. We can iterate through objects using the for-in syntax. Let's see what's up next. Advanced objects.